Thank you everyone to be here today for this great conference from Saleem. So it will be a talk regarding trust and confidence. He has written a book, just like I said earlier, called Learning TDD. It's really good. If you want to learn TDD, if you want to practice TDD, if you want to share TDD, I really enjoyed it, and I think you will enjoy it as well. So don't hesitate to spread the word and to read the book. Floor is yours, Saleem.
Thanks, Johan, and good afternoon, everybody. I imagine most of you are in Europe, and it's good afternoon for you. It's early in the morning for me here in the US. Thanks for inviting me to your group, and thanks for inviting me on, I guess, what's a little bit of an auspicious day, the 22nd of February, which how we write the dates in Europe, at least, is a very nice palindrome. So thanks for that as well. That's me. I think Johan covered what I do and what I've done in great detail. So mostly what I do is consult with clients on all topics software, especially for practitioners. My goal lately, as in for the last several dozen years, has been encouraging and coaching and coaxing people to adopt various XP practices, of course, test-driven development being the primary one. Here are some ways in which you can digitally stalk me, I guess, or follow me. So the topic of today is trust. Trust is an interesting word to define. So before we move on, and this is going to be hopefully an interactive conversation, at least via the chat, which Johan will keep a handle on, or if you want to ask questions as well. So one of the things I want to do is pause and ask you what you think trust is. And if you want to take maybe 30 seconds to either jot down a definition of trust or some notion of trust that you use in a very colloquial way. This doesn't have to be a scientifically true definition, but just imagine in your head, what do you mean literally when you say you trust something or you trust someone? What does that imply? As it turns out, trust is a rather hard concept to nail down because it is it's ultimately a feeling, it's ultimately subjective. So it does defy a very crisp definition. However, that we have some implicit notions of what trust is like. So this is an exercise, or at least a gimmick that I'm sure most of you are aware of. It's called the trust fall. And that exemplifies what you might mean when you say you trust somebody. So if you take this act or this activity and analyze it and see what does it mean when you trust somebody enough to believe that they will support you if you fall backwards. It turns out that there are some aspects of trust that even the dictionary definition can yield. So this is literally the dictionary definition. It's interesting that trust has some kind of fuzzy notions attached even in the definition, a firm belief, and especially without evidence or investigation. So that's where it gets subjective, right? That if you have something that for which you cannot offer any evidence, then how do we scientifically analyze it, or how do we even measure it? If you say, I trust something more than something else, and what does that even mean? Can we analyze it? So in this field, the work of Morton Deutsch has been really seminal. He was a social scientist, and he did a lot of work in the field of conflict resolution, which when you define conflict, you have to first define what is the root of the conflict. And of course, the root of all conflict is some erosion of trust, some lack of trust. So when he set about working on conflict resolution, he first had to define trust, and he did. So this is the definition of trust that Morton Deutsch presented in his work in the early 60s, early to mid 60s, in fact. So it's been a while. And there are some things in this definition that that give us room for pause, that we need to consider. So the way, it's a long definition, but the way he defines it is there is an event that may or may not happen, and the person who is exhibiting trust has obviously two outcomes to consider. That event may happen or it may not happen, right? And the consequences of that event happening are good, positive consequences, and the consequences of that event not happening are negative. And here's the important thing. The negative consequences are greater than the positive consequences. That's the key part of the definition. That is, if that event doesn't happen, the harm incurred by that individual who has to trust or who is trusting are greater. The harm is greater than the benefits if the event that has happened. And in that setup, if the person acts as if the event will happen, then that individual is exhibiting trust. If the individual, on the other hand, acts in a manner that the event will not happen, then that individual is exhibiting lack of trust. So that's a lot of setup, right? So how can we easily understand it? So in this scenario, which we can all very inherently understand, what do you do? What's going on in your mind when you trust somebody enough to kind of expect them to support you if you lean back or fall back? The event is that you are counting on is my partner will catch me. Now that event may happen or it may not happen. Your partner may catch you or he or she may not catch you. But that's, in any event, that's the thing you're counting on. The behavior you do based on this is fall back without looking. That's the action you take. Now, what's the interesting thing? The positive consequence, if the event that you are counting on does indeed happen, is you'll be safe. However, the negative consequence, if the event does not happen, is you would be injured, possibly severely. And there's the asymmetry of this. The negative consequence is much greater in its negativity, in its danger, in its risk, than the positive consequence. The positive consequence, while enjoyable, pales in comparison to the negative consequence if both were to be compared. So in this setup, in this scenario, if the person chooses to believe in the event or act according to that event, then they're exhibiting trust. Whereas if they choose to act in the opposite direction, then they're exhibiting lack of trust. So let's bring it back to the world of software, right? That's also much about falling backwards and the trust fall and all of that. How does that relate to us as software practitioners? Before we go there, trust is, even though it's a hard thing to describe, it is distinct from some other concepts. Trust is not the same thing as risk-taking. It's not gambling. Why? In gambling, normally, when people wager or place a bet, we're not talking about problematic types of gambling addiction, but we're talking about the kind of normal wagering and betting that happens in life. The positive consequences usually are comparable, or in some cases, even greater than negative consequences. You can look at any lottery that you win or even play. The lottery ticket is normally, for most people, is a small and affordable. The loss of not winning is certainly bearable. So if people buy a lottery ticket once a week, or even perhaps once every day, it is hoped, at least one hopes, that they're able to afford it and that doesn't seriously cause them a jeopardy in their earnings. Here, I'm deliberately ignoring the mathematical axiom that playing the lottery is a tax on the mathematically uninformed. That's another way to look at the lottery. But ignoring that, if you buy a lottery ticket costing €1 a month, hopefully that is not denting your budget. But if you win, the positive consequences are great. So gambling is not the same as trust, or does not involve the notion of trust. And we can even see that in our lives. Nobody would, in their right minds, would say they trust that the lottery ticket they bought will win, or they trust the roulette wheel. Nobody would say that, even the gambler. They would say, I'm taking a chance, and it'll be great if I win, but frankly, I don't expect it. Trust is also not the same as hope. The difference here is, while hope can be attached to many different things, great things, you may have hope that humanity will learn its way out of war, or you may have hope that your local sports team may win. Small things, inconsequential things, or large and important things. But the significant difference between trust and hope is, usually with hope, as we define it, there is no or inconsequential behavior attached to it. Hope is merely it could be a vague or it could be a very earnest wish in your heart, but you normally don't do anything for it. If you actually invest, if you take an action based on that, then it gets into the realm of trust. But if you're just hoping that your team will win, or if you're simply hoping that war will end or famine will end, well, then that's just hope, and that's not where we would apply the word trust. Trust has some implications. So trust implies that there is some uncertainty to the outcome. It may seem ironic, but things that are absolutely certain, we may use the word trust in common parlance. For example, you may say, I trust that the sun will come up tomorrow, but that's really, I mean, that's not trust. You're stating what is almost with an almost certainty an event in the future. Or even more so, you wouldn't say that I trust that 2 and 2 make 4. You're stating a mathematical equation. The word trust does not apply. Trust is really useful where there's some uncertainty as to the event that you're describing. It may happen, but it also may not happen. In that scenario, only the notion of trust makes sense. So we don't use the word trust for things that are absolutely certain. And trust implies confidence as well. So of course, if you, and you can even again think about it in normal colloquial sense, all of us, we may have been disappointed by friends, by colleagues, by even family members, but a certain degree of trust is necessary, as they say, to even get out of bed in the morning. I mean, you trust that if you're going to work, that the bus or the train will come on time. If you're showing up for work remotely, you trust that your internet provider will continue to provide service, and then your colleagues will show up and work with you. So there's a certain level of confidence that is required. If you have zero confidence in anything, then that also the trust will immediately break down, because frankly, there would be no reason to get out of bed in the morning. So those are some corollaries of trust that must exist for trust to exist. So now turning our attention to code after this preliminary discussion about what trust is, how does it look like in code? So uncertainty raises its head in many different ways. One aspect is randomness. So here are 2 samples of Java code. On the left side, you don't have to compile this in your head or read through it, but basically there's a random service that uses some randomness to give you an answer, and the probability that the service will return 42 or a maximum value of integer, or frankly throw an exception, is random. So there is randomness on the code on the left, versus on the code on the right, there is another class and it has a constructor and pretty straightforward stuff. It sets a variable, some state in the class when you call the constructor. So we would say that there's zero randomness on the right. Like there's no randomness. The behavior is very predictable, very deterministic, versus on the left, there is a very high degree of randomness. We can't predict what's going to happen the next time we call this method on the right, on the left, versus we are absolutely sure that what will happen when we call the constructor on the right. So those are, in a sense, in a simple sense, 2 extremes of randomness. So uncertainty in code can be due to this kind of randomness. Now, of course, this example on the left, as on the right, is contrived, but you can imagine any other kind of non-deterministic behavior that can yield some randomness, and it may lie somewhere on the spectrum of highly random behavior versus highly deterministic and provably deterministic behavior. So again, this method is random, and on the method on the right is completely non-random, completely deterministic. Another avenue of uncertainty in code can be due to complexity. Now, this is borrowed from the Spring framework. So this is an actual code. This is not contrived, as in this code runs in production, and I would imagine hundreds of thousands, if not more, applications in the world wherever Spring is used. And you can see that this is fairly complex, as in it's highly nested. That gives it away. But we can obviously use a notion of a more scientific or mathematical notion of cyclomatic complexity to measure its complexity. So, cyclomatic complexity is a measure of the cognitive load of a program, in a sense, how difficult it is to comprehend and understand and keep in your head. The mathematical definition is from the control graph, which is basically the number of edges minus the number of nodes plus twice the number of exit points. From the graph, if in a method, in a language that has an explicit return statement, so basically the exit point is each return statement, each point where the method can exit. That definition is, again, quite mathematical. The easier way, given an actual chunk of code or an actual method, is to count all the points where there's any decision to be made. Now, a decision is made, of course, in an if statement, but also in a loop, because when you enter a loop or you don't enter a loop, that becomes a decision. So given this code, the cyclomatic complexity is at least 6, if I counted right. Each of these things has a decision point. The original work of Stan McCabe, who defined this notion, was that a rough heuristic is a cyclomatic complexity of 10 is a reasonably good threshold. So this is within that threshold, but even for whatever, a dozen lines of code, a cyclomatic complexity of 6 is fairly high. So this method, we could say, has some complexity. If you had to understand it, you would have to invest some time. It is not as obvious as that constructor we saw a minute or so ago. So another notion or another aspect that can introduce uncertainty in our code is obscurity. And obscurity is literally code that is hard to read, it may be short, it may not be many lines of code that we're not tired of reading it, it's not that. But it's just its intent is hard to understand just by reading the source code. So here is an example of an actual C program. This is, I think, remarkable in its obscurity, as in this would be really hard for anybody to reason about. And if you're wondering that why would somebody write it, this was written for a competition. There is an actual competition, International Obfuscated C Code Contest, and this was, I would say, a very deserved winner of that competition in 2020. Although I would say obfuscated C code, that's 3 words, and I think at least 2 of them are superfluous. I think obfuscated C code is saying the same thing over and over again. But anyways, that's my opinion. Hopefully I didn't offend anybody by saying that. So this one line of code is literally one line of code, but this is obscure. Its intent is very hard to predict. You may run it and then see what happens and then try to, in a sense, reverse engineer what it's doing. Or you may test it, which would be great. But it would be very hard to claim for, I would imagine, most people who can read C code to say, I can read it and I understand what this is doing. So this is one source of obscurity. Of course, this one is deliberate obscurity in terms of winning a competition. But you can imagine from this example, there are other lines of code that you may have read and you can read them, but you have no idea what the intent was for. So here are at least 3 causes of uncertainty in code. There's randomness, which makes the outcome of the code difficult to predict. What is it going to do? Can't really say for sure because it's random. There's complexity. That is because, or when the code is difficult to keep in your head all at once. So it's not random, it might be very deterministic, but it's just too complex to fully comprehend and keep in your head all at once. And then, of course, there can be obscurity. Code can be literally difficult to read and understand, so its intent is hard to grasp. Now, these 3 dimensions, number 1, are not an exhaustive list. Uncertainty in code can be from other avenues as well, but certainly these are 3 that we can relate to and find commonly. And also these 3, while distinct things, they are not completely isolated in reality, right? So for example, obscure code is very highly likely that it will also be complex. And then of course there is affinity between complexity and randomness, and maybe obscurity and randomness as well. So the point is, regarding the somewhat contrived or handpicked examples that I showed you, in most real examples, if you're seeing one or other of these causes, it is likely that more than one of these causes will be present. So I want to pause here and pose a question. What other causes of uncertainty have you seen? So you might want to note that down in the chat or note it down in your own notes, and then it'll be nice to have a discussion near the end. So given these causes of uncertainty, how can we increase confidence in the face of uncertainty in our code? Because if we are to say that I trust this piece of code or I trust my code base, it has to mean something, again, in the context of the definition of trust that we have been using. So given that we have identified at least 3 sources of uncertainty, how can we increase our confidence given that we have some uncertainty in our code or code bases that we might be using or familiar with? So let's take uncertainty in code because of randomness. So let's say you have a class, a dependency, a library, Zen service, we'll use the same one that we showed before, and you have to depend on it. So you have to write some code that depends on code that in itself is uncertain, either purely random or somewhat non-deterministic, and it behaves differently in different scenarios. It doesn't always yield the same result. And you're rather unsure what is it going to do the next time I call it. So what do you do? How do you reduce uncertainty? How do you prevent the uncertainty in that dependent code from leaking into your code so that the whole thing becomes an ever largely increasing ball of uncertain code? So here's, for example, that uncertain Zen service that we talked about earlier. How would we use it? So one way to minimize uncertainty or control it is to test the uncertainty directly. So here we may not be sure what the Zen service is going to do the next time we call it, but we can test it within the confines of its uncertainty. So what this is doing, again, is marking the Zen service. And this first test, what it's doing is, we don't know what the Zen service is going to do, but if it returns 10, then I expect my service, the meaning of life service, to also return 10. What this is saying is, whatever the Zen service might do, my service should faithfully return its answer when it's within these parameters. So you mark it, and then you inject it into your own class. So there's a potential for increased uncertainty, but we control it by this test where we say, regardless of how and under what circumstances the underlying service behaves, however it does, I expect my code to work in a predictable way, and I'm going to test it. So you're controlling the randomness. You're kind of stopping the door of the randomness at the boundary of that service, not letting it leak into yours. And you can take it further. So the behavior of the Zen service that you care about, you can write different tests for this. So for example, this one says, if the Zen service throws an exception, then I expect my class to throw an exception. And here we literally test that in this particular scenario, when I throw an exception out of the Zen service class and then call my method, it should throw an exception. And the third one verifies that there is a dependency. So you can even test that even though I'm using this unpredictable, somewhat random, non-deterministic chunk of code, I can test my behavior despite using this non-deterministic library. So this last test is verifying that indeed the meaning of life service calls Zen service. It is not achieving certainty by simply absconding and not using that service. That could be a way, right? You could say, I don't want to use this service, and that's how I achieve certainty. But the third test is saying, no, we don't live in our ideal kind of contrived world. We have to use this Zen service, and we will indeed make sure that it gets called. So you can, through a battery of tests, you can achieve the happy medium. You can verify deterministically that your code does what it expects, what you expect it to do. And you can also verify that I'm indeed depending on the service whose behavior in itself is somewhat non-deterministic. So that's what we do in the face of randomness. We isolate it. We can't eliminate it because it happens. There will be code that behaves non-deterministically, but what we need to do is to isolate it in place, set up a boundary so that the randomness doesn't permeate through the rest of the code base, certainly in those parts over which we have more control. Let's turn our attention back to complexity. If uncertainty is due to complexity, and looking back at this method from the Spring framework, what do? So there is a lot of things going on in here, a lot of if statements, a for loop, a ternary operator at the end as well, then a return null. If I imagine none of those things happen, then the ultimate fallback is a return null. So how do we test this? We test this and we inject some sense into this, or we unravel this complexity by recognizing parts of the complexity. So we may not understand the complete method all at once, but we see that, okay, there is something going on right at the top that says if the name, which is the parameter to this method, exists, something happens. Otherwise, of course, this if block wouldn't be entered, and we don't even need to read inside the if. And then we'll fall back to the return null. And then we see a little later, there's another if, which says if the name starts with some prefix, then something happens. And of course, without even reading fully what that something in the if is, if it doesn't happen, then I'll fall back and return null. Okay, so given this method is complex and I cannot understand all of it at once, but I do get these 2 bits, right? So can I do something with this bit of information? Yes, I can. I can couple that with the fact that there's a return null at the end, and I can write tests that reveal what I do know. I may not know everything about the method, but I know some things. So here are 2 tests that will work. And the first one says that when I call this method with an empty string, the return should be a null value. So that's my understanding. I don't know what it does with other values as a parameter, but I have some confidence and I can test it. If my confidence is misplaced, my test will tell me, but I can start there. I can start with that 1-line test to say, when I call the get property method with an empty string, I expect a null value. And the second one is interesting. We notice that we didn't even get into, let me go back a slide. We didn't get into what the prefixes would be, right? The mappings would be in that are defined in the for loop. We could go down that route and increase our cognitive load and say the mappings and the prefixes that are extracted from the mappings, what are the legitimate prefixes in the mappings? We could do that, but let's say we decide, you know what, that's too much cognitive load. I don't want to get into that. I can write a test with a very high likelihood of a prefix that I will not find, which is why we use this, you will never find this prefix. And we can test with that. Without knowing everything, we can still write a test. Now, of course, 2 things can happen. Hopefully the likely event is that this you will never find this prefix will not be found, and the test will behave as you expect. But imagine that that's a legitimate prefix in the mappings. Well, something else will happen. You will increase your understanding because the test will fail or do something that you don't expect. In this case, we're expecting a null value. And you'll learn something about that code that currently, because of its high complexity, is somewhat inscrutable to you. So again, the idea is you can get started even in the face of high complexity. You don't fully understand the entirety of the method because the cyclomatic complexity is high and you can't bear the cognitive load. You can't really put the effort to understand all of it at once in your head. Nevertheless, you can get started and saying the little bits of the code that I do understand, I can test them. When I test them and I run the tests and I see them passing, it gives me slightly increased confidence how this code works, and then I can go on tackle the rest of it. Through this approach, when your source of uncertainty is complexity, you can prune it. You don't have to understand all of it at once. You can understand bits of it, test those bits, and thereby tackle complexity by essentially pruning it down. Okay, let's look at the third cause of uncertainty, which was obscurity. So here is a test for all of you. This is Java code. I'm assuming some amongst my audience can read it. So it's really 4 lines of code. There is a method, it returns an object, and it has 2 variables, and it adds them and returns them. Of course, the interesting bit is one variable is an integer, its name is string, and the other variable is a string, its name is integer. And so I want to pause here. What do you think this chunk of code or this method will do when you run it? Option A, it returns the string 42. Option B, 42, the integer or some number. Option C, a compiler error happens. And option D, a runtime exception happens. If you want, you can put it in the chat. And Yuan, we can look at that later.
It's mostly A for now.
Okay, that's good. That's a good guess. Despite the frankly very obscure way the method is written, it will return the string 42. It is legal in Java. There is a thing, actually it's called obscuring the name of the variable. that allows you to, as bad as it sounds and as bad as it is, you can name your variable with class names. You can't name them with primitives because they're part of the Java keywords, but you can name a variable string and you can name a variable integer. And then of course, as we know, when you use the plus operator, it ends up concatenating as opposed to adding, and you end up with 42. But assuming that you have maybe not this level of really bad obscurity, but some level of obscurity that makes it hard to predict what the code is doing, what can we do? Well, again, in this case, you obviously guessed it, and many of you guessed right. But the thing is, even in this way, in this contrived example, or perhaps a very, I would say, infantile or perhaps even mean-spirited example, which seems like it's written deliberately to throw people off their rocker, we don't have to worry about its obscurity. We can test it. And we can say that if we create a new instance of this object and call this method, I expect 42 to return. Now, two things will happen. Either the test will pass, which is great, in which case my prediction would have proven out to be wrong, or the test will fail, and the failure will tell me what the expected value is, or the actual value is. And I will gain new insights despite in the face of this obscurity. So what should we do when there is obscurity? We clarify it. We don't have to, again, insist on all code being not obscure. That would be great if we have control and we can remove the obscurity. In this case, of course, you could just rename the variables to be better named and just remove the source of the obscurity. But imagine in most cases, you either have the time nor the inclination, or sometimes even the control, using a third-party library whose source code you are either legally or contractually not allowed to change, and the obscurity remains. But you can at least write tests to clarify the obscurity. The test will add the missing relevance, the missing cognitive clarity that is missing in the original code. The test almost becomes an add-on that says, this is what should happen in this chunk of code when we call it, even though the code itself really doesn't reveal its own intent all that much. So that's all about, or most of what I wanted to talk about, trust in code, which is definitely one part of what we do. But the definition of trust is not limited to inanimate objects. We can use the term trust to define code, certainly in the face of uncertainty of different types, these are 3 types we saw. But that's only a partial usage of what we even in colloquial sense use the word trust for. We do use the word trust for people as well. So we say we trust somebody, or we don't trust somebody, or we trust somebody more, we trust somebody less. We use that even in professional settings. So what does that look like? And what are the implications of that? So the classical problem, or I guess the demonstrator for trust in people, is what's called the prisoner's dilemma. And this was also originally defined by Morton Deutsch in his paper. And this is takes a little bit of an explanation. So if you know what prisoner's dilemma is, you can take I guess, a coffee break for the next couple of minutes while I describe this. But if you don't, here's this simplified example. The green person in green, the green person has to choose between these 2 rows, and the blue person has to choose between these 2 columns. And what happens? Neither one of these people, we assume, is aware of the other people's intent, right? So both of them are making the choice independently, without consultation with each other, without even knowing what the other person is going to choose. So the green person who's choosing between row 1 and 2 doesn't know what the blue person is going to do, and vice versa. And based on the sum of their choices, so of course, one of them will choose a row, one of them will choose a column, so we'll end up in a particular cell. They will get whatever is they have collectively chosen and what matches their color. So the blue person will get what's in the blue circle in that cell, and the green person will get what's in the green circle. Now, obviously, some choices are more desirable than other, and some choices are very undesirable. You don't want to end up with poop, so hopefully you don't end up there. But here's what happens. Both of them choosing rationally, if they were to choose rationally, will end up in the bottom right quadrant. Because what will happen is, if you look at it from the blue person's standpoint, they should rationally choose column 2, because that's where the big $ sign is. in the second column. So they should really try to maximize their gains. And you could even say, even if they were trying to minimize their losses, because they would say, I get less poop in the right column, so I should choose that. And similarly for the green person, they would end up choosing the second row, because that's where the bigger dollars, the bigger money for them is. Or similarly, they could, if they're risk averse, they could say, I want to minimize, so I'm going to choose the second row. And both of them, without consultation with each other, without knowing what each other is doing, would choose column 2 and row 2 respectively, and end up with no wins, and frankly, a little bit of bad effect for both of them. Whereas what obviously they should have chosen to maximize the collective benefit is row 1 and column 1. They should have ended up in the first cell. So everybody got a little bit of money, but they won't. And here's the interesting bit. And this is the experiment that Deutsch ran. And he realized that two rational individuals are likely to not cooperate, even when it's in their interest to do so. That was the interesting finding of the prisoner's dilemma, that rationality in itself does not guarantee, not only does not guarantee collective good, like we will make decisions that benefit all of us, it also doesn't guarantee, rationality does not guarantee trust, which is a very fascinating finding, because most of our, especially as software engineers and people generally with a scientific bent of mind, we might be inclined to rationalize our way out of a non-trust relationship without realizing that rationality is no guarantee towards increasing trust. It is collaboration, and it requires empathy, and it requires, frankly, a bit of forgiveness, notions that the scientific mind finds hard to accept because they're hard to reason with. They're counterintuitive, frankly. So there's an iterative version of the prisoner's dilemma. This was other people built on Deutsch's work. And what they did is, if you run the prisoner's dilemma one time, chances are both parties will choose rationally in their self-interest and end up making a collective decision that's bad for both of them. But what if you let the same two parties, same two players, the same two humans play over and over again? What will happen? And this is where things get interesting. If you run the prisoner's dilemma over and over again, being nice, and we can define nice. Nice involves forgiveness. It means non-retaliation. So if somebody in the last situation made a choice that was bad for you, you don't retaliate and now make a choice that's bad for them. You don't do tit for tat. And there's some other metrics that are measurable. So if the two people adopt a strategy that is nice, over the long run, they always end up creating more advantage for themselves collectively than being selfish. So that's the interesting finding. And what that leads us to is what I like to call the programmer's dilemma, that while I could write obscure, complex, or non-deterministic code, and it may have short-term benefits, I could get away with it, maybe even medium-term benefits. Some people pejoratively use the word job security. If you write that kind of code, if you're the only one who understands it, then frankly, you're the only one who's going to be asked to help fix it. Good or bad, you certainly have your job security. So while it may have short-term benefits if I was to create this kind of code or other kinds of code that reduces trust in code, the problem is I work in a team, and my teammates are stateful sentient entities, as in they're humans, and they remember. So over time, what we end up doing in a team structure is we are repeatedly playing this prisoner's dilemma. And it's not a one-time thing only. For any substantial piece of software that obviously requires, software is a team sport, so it requires a team. It's not a one day or one commit and you're done deal. You're gonna work with the same people for months, if not years. And people do remember. So in the long term, if you choose to act in the selfish way, which is maximizing self-interest, you are not going to maximize returns for yourself over time, and certainly not collectively for the team. So you're going to end up in what was the bottom right quadrant over and over again, where you will not have the benefits you sought, and your teammates will not have the benefits. So the collective will not have the benefits either. So therefore, going for short-term benefits is essentially like checkmating myself, playing chess with myself and checkmating myself. Doesn't really yield the benefits I seek for myself either, let alone the collective benefits for everyone. So you don't get it by acting with pure rational self-interest. So what can we say? We go back to the definition that Morton Deutsch gave. Trust is related to positive and negative motivational consequences. And when the expectation is met and positive consequences happen, it increases trust. And when the expectation is not met and negative consequences happen, then it decreases trust. If we frame this in our minds, then here's what I would call the programmer's edict when it comes to team members and trust. We should act in ways that increase the likelihood of positive consequences. And we should also act in ways that decrease the impact of negative consequences. Now, the two words are carefully chosen because what we cannot do, the very nature of trust, or certainly in scenarios where it's relevant, the negative consequences far outweigh the positive consequences. That is the nature of trust, as we said, that it hurts more than it helps, right? If the trust is betrayed, it hurts more than if the trust is upheld. Things just work normally as expected. So that doesn't feel so good, but when trust is broken, it feels really bad. That is the nature of trust. So we can't really say reduce the likelihood of negative consequences, but we can reduce their impact. And we should increase the likelihood of positive consequences so the trust is really not broken in the first place, at least not often enough. That is the mantra, or that's the programmer's edict that I believe we can adopt and we should adopt when working in a team sport, such as software. And of course, here's an interesting quote to end this on. Always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Now, if you can't work your way up to trust, fear is a very decidedly second choice, but certainly one that we can fall back on. In teams, when you're creating software, and it might be a future version of you, which you're helping, but always think of the maintenance developer, the people who have to live with the code you create. And if it helps you, then assume that they have ill intent, and maybe that's the motivation you need to create code and put the effort right now to essentially increase trust in your teammates and your code. That's all the slides that I have. Thanks so much for your time. And I'm going to put it back to Jan, if you want to read the questions or some feedback, or if people want to unmute themselves and ask questions. Let's have it.
Yeah, thank you, Saleem. Thank you so much. Yeah, I kindly invite people to unmute themselves and to ask questions directly to you. It would be easier, I think. There is no question on the chat for now, so don't hesitate to ask it directly, to ask yours directly to Saleem. It will be easier, I think. So who wants to start or give feedback, just like you said, Saleem? No one?
I have one.
Yeah.
So, hi, Saleem. Thanks for the presentation. It's not really as a question per se, but from my experience, trust is always harder on people than it is on the code. What are maybe tips you can provide, or I don't know, advices maybe to try to increase the trust within a team?
Yeah, good question. Thanks for asking that. And you're right. I guess in the sense that I can concur with your observation, especially for people who write code for a living, it is easier ultimately, or certainly we have more techniques to increase our trust in code, the inanimate parts, than with people, right? For one thing, we know that, and this may sound a bit odd, that code is not malicious. It may be really bad, it may be horrible, it may be non-deterministic, it may be unreliable, and we might even claim that it's out to get us, but it's really not out to get us. Sometimes it's hard to make the same assumption despite good faith about people. So there are reasons that it's hard to achieve similarly, or at least the tactics that we use to increase our trust in code are not the same as we would use to increase the trust in people, which is, I think, the thing you're saying, and I agree with that. As to the strategies or tips, I think it's the social scientists have done a lot of work, so I encourage you to read Morton Deutsch's paper and the research in that. But in a nutshell, if you start from that notion that acting in self-interest purely rationally is not going to get it done, which probably I would imagine is a hard first thing for rational people, especially programmers, to frankly tolerate or gulp down. That rational behavior by itself will not give you higher trust. So the next question is, what will? So again, that's some of the things that we have known is forgiveness is a good trait to have. Assuming good intent is a good trait to have to increase trust between people. And the values of XP, extreme programming, which include both confidence in yourself and your team. And another value is strength, or I think courage, as Kent Beck has called it, which is having the word courage is, again, we could have a conversation about what courage means in that XP context, but the word courage doesn't necessarily simply mean doing the hard thing by yourself or being brave or kind of blazing through or putting an all-nighter or whatever. It also means having the courage to have tough conversations. So for example, and maybe this can relate to you as a practical thing, if you're in a team where you have a particular teammate who you see regularly or consistently writes code that is not tested, that breaks the build, and that the person then relies on others to clean up after them, the thing to do there is, there's no amount of rational thinking that will solve that, right? It's a courageous conversation that you need. And maybe there are reasons, maybe that person doesn't know, maybe they need training, maybe they need mentoring. But wherever you end up, the first thing to do is, after, of course, the original realization that that's a pattern, is really not so much any mechanical thing you do, it's really a courageous conversation with that person. So courage, that definition of courage, I think, is also necessary. And this is also derived somewhat mathematically from the prisoner's dilemma experience, where being merely nice over time doesn't work for the collective good. And because rational choices defeat that, right? So for example, what being infinitely nice might look like. Let's say one of your colleagues doesn't write any test, zero test, and you have the conversation and they say, nah, I'm not gonna write it. And then you write all the tests for them. You go refactor their code. You keep doing that. That is bound to, or you or other people kind of cover for that person. That is bound to yield negative results over time. That is, that's not going to increase anything, including trust. That's not going to improve anybody's trust either, let alone the quality of the code base. So that is not the behavior we want. We want courage so that the collective trust can be increased. So again, that was a slightly longer answer, but again, to recap, forgiveness, empathy, assuming good intent, and the ability to have courageous conversations. Those are some of the traits that I found helpful to increase trust amongst people.
Thank you very much. It was indeed a long answer, but I really love the perspective. Thank you very much.
Cool. Ravi has I think a question or a comment there.
Yeah, it's more feedback for you, a positive one. So,
okay.
Yeah. If you want to explain already, maybe you can also talk about what you have discovered in the book, because I've seen you have already read some chapters from Saleem's book.
Hey, yeah. So, yeah. So, what I just want to thank Saleem, for spending time with us today. What I was mentioning is I've read quite a few books on testing in general and about TDD, mainly because I was looking for ways to convince my team members to start doing TDD. They were all convinced that writing tests after was enough. I'm glad they were writing tests, so there were some automated tests, which, like you mentioned in I think the preface of your book as well, some tests are better than no tests. But yeah, I really, one of the books that I've really enjoyed and sort of reread multiple times over the years is The Art of Unit Testing. I really love the ideas that are there in the book, but I always struggled. I think it's in C sharp. If I don't even remember the language because I just sort of read the words and sometimes don't see the code examples. But I went through a few chapters of your book and I'm really excited by what I see. Of course, the content's amazing, but the style in which you've written it also sort of got me. So I just started reading the book yesterday, and I went through I think a couple of chapters already. So I'm really excited by what you've written. I'm really looking forward to finish it. I chose to go down the route of trying examples in all three languages to sort of understand how it works in each of the different types of languages. So yeah, really just thank you for writing the book. Thank you for being with us here today. That was just a comment from my end. Yeah, no questions about what you said so far. Thanks a lot.
Thanks, Ravi, for those kind words. And yeah, it's great that you're trying it out with your teammates. Really enjoy it. I'm really fascinated that you're reading the book. Would love to hear your feedback once you're done with it. And we'd love to hear your thoughts on what taught you or what you learned or what it inspired in you. Thanks so much.
Absolutely, yeah.
I have a small, maybe a remark. Isn't most of the uncertainty, like the randomness, complexity, and obscurity, isn't it linked to the changing business environment, like specifications that change, business changes, people change team? So you have a lot of movement, and maybe that's one of the reasons why sometimes you have uncertainty in code. Not always because people are not willing to write tests or willing to do better. Would you agree on that?
Yeah, that's an interesting. I don't know if I have enough information to say if most of the uncertainty because of that, but that certainly it's very plausible, right? And what you're hinting at there is what I would call the cognitive loss, right? So let's say you have a team of whatever, 4, 5, 6, 10 people, let's say even a large team, 12 people. And over time, they have built this, not just this trust in each other, which of course is very important in what we're talking about, but this mutual vocabulary and this what you might call business knowledge or technical knowledge. And then there's churn, as you're saying, team members change, or perhaps because the business domain changes, the knowledge they built up, that team built up is no longer relevant. And that can cause a decrease in trust. So there's definitely that cognitive loss when you build up expertise over time, whether in your code base or the business domain or what have you, on all of that, that certainly contributes to increased trust. So conversely, as I think you're saying, if you lose that because your team is experiencing churn or other things like that, then you will lose trust. So I certainly do agree with your premise. I just don't know enough to say whether that's the largest reason. Normally, like that would obviously require some analysis. But I would agree with your thesis that certainly one way to increase trust is to have some stability around those parameters. And conversely, as I think you're saying,